What's up everyone, welcome to the channel, and today we are going to look into the bubble sort algorithm, which is I think one of the most simple and easy to learn sorting techniques if you are a beginner in coding. We are first going to look at how this technique actually works, then we look at the algorithm and then the coding part, because I think if you can understand and write the algorithm by yourself, then the coding part becomes very easy. And in the end, I'll also tell you how to optimize the code. So let's start with the explanation. So the bubble sort technique, what it does is it goes on comparing all of the adjacent elements in an array or list from the first element to the last one and swapping their positions if it is required till all of the elements come into their correct positions. The condition for the comparison has to be specified by us depending upon whether we have to sort in ascending order or descending order. Now let's look at how this algorithm actually works. For example, we have here an array of 5 random numbers which are unsorted. Now the bubble sort technique, what it will do is it will start comparing all of the adjacent elements from the first position or the 0th index. The first element here is 7 and its adjacent element is 6. These two will be compared on which one is greater or smaller. Suppose here we want to sort the array in ascending order. Then we'll check which of the elements is greater and swap their positions if the greater element comes before the smaller one. So in this way, what will happen is the larger elements will get bubbled up to the position where they should belong by the end of this algorithm. So if we compare 7 and 6, we find that 7 is greater than 6. That means it should come after 6. So what will happen is we'll swap the position of 7 and 6. So the array will then look like this. Now the next two adjacent elements are 7 and 1. And 7 is greater than 1. So we'll swap their positions again. Now the next two adjacent elements are 7 and 4. Again we'll compare these two, and if we compare we'll find that 7 is greater than 4. Again we'll swap their positions. Now the last two adjacent elements remain 7 and 2, and the greater one among them is 7. So again we'll swap their positions. Now you see here we have reached the end of the array and compared all of the adjacent elements. So this whole set of operations here is called a pass, and here we have finished the first pass. Now we'll move to the next pass and again start comparing all of the adjacent elements from the beginning. So at the end of the first pass we find that 7 has moved to the last position in the array. Again we'll start from the beginning for the second pass. If we compare 6 and 1, we find that 6 is greater than 1, so we will swap their position. Again we'll compare the next two adjacent elements, which are 6 and 4. So 6 is obviously greater than 4. We'll again swap their positions. Again we'll compare the next two elements, which are 6 and 2, and 6 is greater than 2, so we will again swap their positions. Now the last two adjacent elements are 6 and 7. Again we'll compare them, but here 6 is not greater than 7, therefore we will not do any swapping and the array will remain as it is. This will complete our second pass. Now for the third pass, the array is looking something like this. We'll start comparing from the beginning. 1 is obviously less than 4, so no swapping will take place. 4 is greater than 2, so their positions will be swapped. 4 will be compared with 6, but 4 is less than 6, so no swapping will take place. And 6 is less than 7, so no swapping will take place. This will complete our third pass. Now we'll move on to pass 4, and this is where the drawback, you could say, of this algorithm comes. Here if you see that at the end of pass 3, the array is already sorted, but still the algorithm will go for the next pass and again compare all of the elements, because the algorithm doesn't know that the array is sorted. This is because it may not always be the case that after 3 passes or after n number of passes the array becomes sorted. Suppose here we had 2 instead of 1 and 1 instead of 2. That will definitely require one more pass after pass 3. That is why the algorithm goes for the next pass. But later during coding we'll also learn how we can avoid this from happening. So for pass 4, all of the comparisons will again happen from the beginning, and at the end what we'll get is a sorted array which looks like this. As the array was already sorted and all the elements were in their correct position, so no swapping took place. Let's look into the algorithm now. The name of the algorithm is bubble sort, and it will take in one argument, which is the array which has to be sorted. Next we will initialize a variable n, which will store the number of elements in the array. After this we'll run a for loop from 0 to n minus 1. This loop is for the number of passes required for the sorting. So if you remember, in the example we had 5 elements and the total number of passes it took was 4. So if you have n elements, the number of passes would be n minus 1. So for 5 elements, this for loop will run from 0 to n minus 1, that is 4. Next we'll run another for loop from 0 to n minus 1. This is for comparing all of the adjacent elements inside the array, and inside this loop we'll have our if condition where we will check whether the element is greater than or less than the element next to it, and for that we will use the index of the element. This is why this loop runs from 0 to n minus 1, because you have to compare all of the adjacent values using their index. In case of 5 elements, the last element's index will be 4, and if you run this loop from 0 to n, which is the total number of elements, then the value of j in the last iteration will become 4 and you won't be able to do any comparison because there will be no element next to it, and you will get array index out of bounds exception. But if you run the loop from 0 to n minus 1, then the value of j will only reach till the second last index of the array, and then the last elements and the second last elements comparison is possible. Now if the condition is satisfied inside if, that is if the element is greater than or less than the next element, then swapping of their positions will take place. Otherwise the loop will move on to the next iteration. That is all for the algorithm. Now let's move on to writing the code. So we have our class here, and inside the bubble sort class we have our main function. We'll first initialize our array. Let's just put the same values we took in our example. Then we'll initialize the variable n and store the number of elements in the array. Next we will write the first for loop, which is the outer for loop. This will start from 0 and run from 0 to n minus 1, and the inner for loop will also run from 0 to n minus 1. Then we'll have the if condition inside our inner for loop where we'll compare the adjacent elements, and if this condition is true, then this part will run where we will swap these two elements. Now let's print this array to see whether the array has been sorted or not. And for that we can use an inbuilt method in Java, which is arrays.toString. Instead of looping through every element, we can use this function directly to print the array. So this will be for sorted array, to print the sorted array, and we will copy this code and print the array before it went inside the loop to see if there was any difference. Let's compile the code. So you see the sorted array and the unsorted array. If you remember, I told you that in our case, when we went through all of the passes, we noticed that after the pass 3 only all of the elements in the array got sorted, but pass 4 was also running unnecessarily, and I told you that I would teach you how to avoid this from happening. So for that, what we can do is we can initialize a variable flag inside the outer for loop. This will tell us whether any swapping is taking place or not. If there are no swapping taking place, that means the array is already sorted and we don't need to move ahead. So we'll declare this variable inside the for loop, and inside the inner for loop we'll check whether any swapping is taking place or not. If the swapping is taking place, then we don't need to break out of the loop. That means more steps have to be done further and more passes are required. But if no swappings are taking place, we don't need to move ahead into the loop. We have to just come out of this loop. So for that, we'll check inside the outer for loop whether the value of flag has changed or not. This will indicate us whether the swapping took place or not. To further optimize this code, what we can do is, if you remember, after every pass, the value which is the largest gets shifted to the last position in the array. Suppose for pass 1, if we see The value which was largest was 7. It got shifted to the last position in the array. In pass 2, 6 was the second largest and it got shifted to the second last position in the array. But inside the inner for loop, we are unnecessarily comparing all of the adjacent elements till the last element. We don't really need to compare the last elements which have come to their correct position. So to avoid this, we can simply run the inner for loop from 0 to n minus I minus 1. This means that depending upon the pass, the loop will either run from 0 to last element for the first pass or 0 to second last element for the second pass and so on. And in this way, we will avoid unnecessary computation time. Now let's look at the time complexity of bubble sort. Assigning a value to a variable is constant time operation. So step 2 will take order of 1 time complexity. Next we have the for loop which runs from 0 to n minus 1. So we can say the time complexity is order of n. The inner for loop also runs from 0 to n minus 1, or even if you run from 0 to n minus I minus 1, still the time complexity would be order of n. Comparing any two variables inside the if condition will take order of 1 time complexity, and swapping is also a constant time operation, so it will take order of 1 time complexity. So we can say basically that the time complexity for bubble sort algorithm is order of n square, because there are two nested for loops, and in best case, that is when the elements are already sorted, still the first for loop runs 1 time and the inner for loop runs n times. So best case time complexity is order of n, and worst case time complexity would be order of n square. Okay, so this is the end of the video. Now I would request you to write this code by yourself and see how it works, because that is the only way to learn. And if you like this video, or if I was of any help to you, then please leave a like, and if you did not like this video, then please leave a dislike so that I know that I have to improve in my next video. Thank you for watching.